In this video, we are going to learn regarding the cyclone separator. So here we are going to focus on the principal part, construction, working, merits, demerits, and the applications of cyclone separator. Principle of cyclone separator. So regarding its principal part, how the cyclone separator is going to work. So basically the principle of cyclone separator is centrifugal force. How this centrifugal force is created. So when a stream of air containing the particles enters the cyclone, it spirals downwards and outwards, creating a centrifugal force. This force pushes the particle towards the cyclone wall, where these lose the momentum and fall into the cyclone collector bin. Here in this diagram we can see the cyclone separator, which is here the stream of air is introduced through a tangential inlet, which is not shown here. Tangential inlet means it is not in a straight path, it is like this type one. So when a stream of air is passed through a tangential inlet with a high velocity, then what happens? Due to high velocity, the tangential the stream of air is entered in a cyclone separator. So here, let me show in the diagram. So the shape of the cyclone separator is in the form of conical shape. So when the air enters with a high velocity, here some blades are provided, spiral blades are there in the cyclone separator, due to which it will provide a circular motion. It will provide a circular motion to the stream of air which is entering with a high velocity in this cyclone separator. Due to this circular motion, it will produce a centrifugal force. Due to the centrifugal force, what happens? The dust particles or the solid particles which are present in the stream of air, they get, if the more denser particles means the particles which are larger in size, they are going to collide or they are going to hit to the inner walls of the cyclone separator, and they will slide down and they are collected in the collector bin. And the particles which are lighter in size or smaller in size, they are get suspended and they are removed from the outlet of the air through the air outlet, through by which construction of cyclone separator. It consists of a cylindrical or conical body and an inlet for the gas stream, an outlet for clean gas at the top, and outlet for the collected particles at the bottom. So here are the different parts of the cyclone separator. The first one is inlet duct. So inlet duct is one through which the air with a high velocity or the stream of air is going to introduce. That is called as inlet duct. The next one is cyclone body. So cyclone body refers to this structure of the cyclone separator which is conical in shape. That is why it is called as cyclone separator or cyclone body. The next one is dust discharge. So dust discharge is nothing but the receiver, or we can say the collector bin, where the separated larger particles is going to collect from the stream of air. The next one is vortex finder, that will direct the clean gas or air. That is working of cyclone separator. So as we know, the cyclone separator is used to separate the dust particles or solid particles from a stream of air. So it is designed like that one. So the first point is the air inlet. So the gas, steam or the air which is going to enter into the cyclone separator, so it is entered in a tangential inlet. So tangential inlet means it is like this one, means the air is not going to enter in a straight line or in a straight path, so it is forcefully allowed to enter in a tangential inlet, so that it will influence, or it will going to support the support in production of centrifugal force. The next one is separation. The centrifugal force pushes the particles outwards against the cyclone wall. So the when the stream of air is going to introduce with a high force in a tangential inlet in the cyclone separator, so the air is going to enter in a circular path. Air is going to enter in a circular path, and the spiral beds are is also provided there, which will help in producing the circular motion of the air. Due to circular motion of the air, what happens? There is a generation, or there is a production of the centrifugal force. Due to the production of centrifugal force, the larger particles which is present in the stream of air, they are going to hit to the, or they are going to collect, they are going to hit to the walls of the cyclone separator, and they will lose their momentum, and they will lose their momentum, and they will slide down, and the larger particles are collected in the collector bin, and the finer particles which is going to suspend in the stream of air, and it is removed through the outlet. That is, so that in this way the larger particles, or the solid particles, which is going to separate from the stream of air by using the cyclone separator. Work applications of cyclone separators. The first one is dust collection. It is used in the industries to remove the dust and particulate matter from the industrial exhaust gases, thereby minimizing the air pollution. And it is used in material recovery. In industrial like mining, recycling, and agriculture, they are used to separate the valuable materials from the waste streams. The next one is pre-cleaning, used as pre-cleaners for the dust removal systems, enhancing the overall efficiency of the process. And it is used in the pharmaceutical industries uh, to achieve high levels of purity in air systems, ensuring that the production environment are free from contaminants. And in industrial processes like cyclone separators are commonly used in industries such as cement, steel, chemical, and woodworking to remove the particulate matter from the exhaust gases. And dust collection systems. Many woodworking shops using cyclone separators in their dust collection system to remove the wood chips and sawdust from the air before it reaches the main collection unit, enhancing the efficiency and lifespan of the filtration system. And it is also used in gas and oil industries. In petroleum sector, cyclone separators are utilized to remove the liquid droplets from the gas streams, ensuring that the downstream equipment operates efficiently and without damage caused by the liquid contaminants. Merits of cyclone separator: low operating cost, so it requires minimum energy consumption and no moving parts, reducing the maintaining cost. Then high efficiency, effective in removing the larger and medium sized particles from the gas streams. Then simple design, relatively easy to manufacture and install compared to other dust removal systems. Then efficiency, effective for removing the larger particles. Then low maintenance and simple construction with no moving parts, and it is durable, durability withstand harsh environments. Demerits of cyclone separators. Although it has some advantages, it also has some disadvantages also. The first one is limited efficiency, not as effective in removing the fine particles, means it cannot be remove fine particles efficiently. The next one is potential for erosion. The abrasive particles can erode the separator inner walls, means if the sample contains the abrasion particles, that will definitely cause harmful effect, or you can say the erode the inner walls of the separators, and it requires periodic maintenance. The another one is limited application, and it is not suitable for highly viscous or corrosive materials, so that it cannot use widely, so the use is limited.